Good morning, madam. We are from Group 1. We choose an engineering that are seen in daily life and going to explain how trigonometry are used in it. These are my group members. Sanjay Kadir, myself, Vasan, Arun Kumar, Balakumaran, and Vijay. As you guys can see the picture, can you guess what engineering we choose? Yes, we choose flight engineering. Trigonometry in flight engineering used for landing, optimal heading, and takeoff speed. First, we are going to see the landing. When pilots are landing, they need to visually maneuver their plane to find an approach angle. The standard angle is 3 degrees and final approach usually achieved at 500 feet. As you guys can see a closer look at the example, x taken as the distance and the 3 degrees as an example. So that 3 degrees equal to 500, which is known as the feet over x, so that we can find the perfect angle for landing. Next, we are heading for the optimal heading. Optimal heading is the direction you should fly your airplane to compensate for the wind. Take a closer look at the triangle. There's the actual velocity down there, and between the start and velocity, there's the angle of optimal heading. Velocity of the wind is the inclined angle. From this, we can find the optimal heading. Next, we are going for the takeoff speed. If you want to take off successfully, we need to detect what angle is the wind is coming on the runway. Take a closer look at the triangle. There's a necessary speed at the runway according to the plane. Wind speed can detect so easily according to the triangle at the picture, so that we knew that how fast we need to go to take off the plane. After this, you guys going to see some sample questions according to the topic we choose, presenting by my teammates. Thank you.
A very good morning to our lecturer, Puan Mazia Male. My name is Arun Kumar and I'm from DEM 1A.
And I am Balakumaran from Dem 1A.
So this is the question that we have chosen for this trigonometry presentation.
And here is the question.
An army pilot is flying an airplane at an altitude of 1200 meters, observes some suspicious activity of two ships which are sailing towards it in the same directions and immediately report it to the Navy chief. The angle of depression of the ships as observed from the airplane are 60 and 30 respectively. Find the distance between the two ships. Here are the solutions. So to find the adjacent length for the ship 1, first we have to find the angle at the ship 1. To find angle, we have to minus 180, minus 90, and minus 60 to get the angle at ship 1. So we will get 30 degrees. And to get the adjacent length, we have to use tangent, which is equals to opposite of adjacent. So we have to substitute the angle 30 into the equation. So tangent 30 equals to 1200 over adjacent. Adjacent equals to 1200 over tangent 30. So the length equals to 2078.46 meters.
To get the angle at ship 2, we have to minus 180 minus 90 minus 30 degrees and you will get 60 degrees at ship 2. To find the adjacent length between the ship 2 and airplane, we have to use the same formula, which is tangent theta equals to opposite over adjacent. And we have to substitute the 60 degrees angle into tangent theta equals to opposite over adjacent. So you will get tangent 60 degree equals to 1200 over adjacent. To find adjacent, you have to divide 1200 over tangent 60 degree, and you will get the answer 692.82 meters. So to find the distance between the two ships, we have to minus the distance between ship 1 and ship 2, and you will get 1385.64 meters. So thank you.
Thank you.
Hi, my name is Vijay Huduli, and now I'll be explaining one of the common problems in flight engineering where trigonometry can be used to solve it. This is a situation where an aircraft has to change its ground speed and course after considering the wind's speed and its direction. So here's an example question. An aircraft is heading north 0 degrees with an airspeed of 100 knots. The wind observed is coming from 240 degrees with a speed of 30 knots. Find out the ground speed and drift of the aircraft. Okay. Before we begin, we'll be drawing a diagram based on this question. So in this case, we'll be replacing speed with length, and it's going to be millimeters. So the aircraft is heading north 0 degrees. So it's going to be a straight line heading north, and it's going to be 100 millimeters long. Now we're going to draw the line or the direction of the wind. We're going to be using this as a reference. It says the wind is coming 240 degrees with a speed of 30 knots. So 240 degrees over here. The line is going to be straight line heading this way, like this. It's going to be the wind. Now, the next step is going to be finding the angle between the wind's direction and the aircraft's direction, which is going to be the x. Before finding x, we're going to find the value of y, and y is going to be 240 degrees minus 180 degrees. We'll get the value of 60 degrees. And x is going to be 180 degrees minus y, which is going to be 120 degrees. Now, it says the wind is traveling with a speed of 30 knots, which means the wind's length is going to be 30 millimeters, like this. Our next step will be connecting these 2 points with a line. Now, this line is going to be the ground speed of the aircraft, or the new direction of the aircraft. And it's heading this way. Now, we're going to relabel the whole diagram into A, B, and C. And then we can insert these values in the formula later. Now, the question is asking us to find the ground speed and the drift. In this case, the ground speed is going to be A, and the drift is going to be angle C. In order to find A, we'll be using the cosine rule, and in order to find angle C, which is the drift, we'll be using the sine rule. After we insert these values, we'll get the ground speed and the drift of the aircraft. And from here, Wasim will be taking over, and he will answer the rest of the question. And that's all from me. Thank you.
An aircraft is on a heading of north 0 degree with a TAS of 100 knots. The wind observed is coming from 240 degree with a speed of 30 knots. In this case, to find drag and ground speed, gonna use which is a square equals to b square plus c square minus 2bc cos a. To find drift is sin a over a equals to sin c over c. Now we're gonna insert the value in this formula. Step 1 is a square equals to 100 square plus 30 square minus 2 multiply 100 multiply 30 cos 120 degree. Next step is a square equals to 10,900 minus multiply negative 3000, and then we get this equals to 10,900 plus 3000. Last step is equals to square root 13,900. Final answer is 117.89 knots. To find drift, what we're gonna do is sin 120 degree over 117.89 equals to sin c over 30. Sin c equals to 0.22. Last step and answer is c equals to sin inverse multiply 0.22. C equals to 12.71 degree.
In conclusion, we can say that trigonometry plays an important role in flight engineering. Let it be finding distance between two objects while in a flying aircraft, determining the aircraft's ground speed, landing, takeoff, and so on.
We also can't deny the fact that trigonometry is used in our daily life, hence it's better to know and learn about it. Lastly, we hope you like the video and have a better understanding about the use of trigonometry in flight engineering. Thank you.
Thank you.